Good morning, all, and thank you for that introduction, John. I thought you were going to say welcome from Radio Luxembourg there for a second with that introduction, so thank you for that. I hope everyone is well. Already we're seeing hi from New Zealand, so thank you for joining us. We've joined today by Ivan Carter, who's our technical manager at Selectronic, and I look after the sales side of things. So we do need to put a bit of disclaimer in here. This is an introductory session. We did go through the list of attendees today, and there are a few of you I see in there who are who are experienced. And if you're looking for just maybe a bit of a refresher on a few bits and pieces, great. But this is aimed at it will go through a lot of the introductory type of technology that we're using. But we'd love you to stay around anyway if you're wanting to do so. So, what are we here for? We're here for understanding some of these storage systems. Storage and backup systems really quite important. So, let me just get my act together here. Quick bit about the company for those who might not have been aware of us in the past. Selectronic, 56 years old this year. 64 we first started. We're a family company, a private family company now in our second generation of family, now run by Ken and Rod Scott. So if you have a quick look at our history, then 64 we were making inductors and coils and various things for what was then the television and radio manufacturing in Australia. Went on to make some lighting inverters. We did our first power inverter in 1981. So just a lazy 39 years ago for inverters, but 56 years ago for the actual company. And you'll note some of the outstanding technical features of that inverter power on the right-hand side there. Huge 360 watts of power connected to the battery through alligator clips, heavy-duty alligator clips, of course, and a handle on the top, as you would expect to do, and it sat on a shelf.
And you have to love the fact that there's that computer as a whopping power machine in the picture as well.
In fact, no battery fuses, but the later versions did have a very large HRC fuse, just the fuse itself soldered onto the circuit board. And I can remember actually soldering those with the big Burco iron onto 3-ounce copper circuit board. But anyway, let's not get distracted. Bit scary that I can remember that. So what we want to make sure that we've actually got covered is that understanding the topology that is used by a Selectronic system, a storage system and backup system. And we do stress here that we're starting off looking at the on-grid, but these are backup systems as well as storage systems. So with the Selectronic system, we utilize two components. You'll find that some systems in the marketplace will use a single component where they'll have basically all the things in one box, all the hardware in one box, where we use a separate mechanical box, if you like. We've got our battery inverter, which is the SP Pro, and its job obviously is to put energy into the battery, DC energy, and take it out and convert that or invert that to AC to create the 240 volts for us to run our house and our lives. The second part is that we need some sort of a solar controller. We've got to get renewable energy into that battery somehow. So there's two options with an on-grid situation. The first one would be what we call AC coupling. AC coupling is going to be injecting the PV onto the AC bus side of the system. And we're looking in an on-grid situation here. This is what we call generic AC coupling, because we could be using any grid inverter out there on the market. Don't care. It's going to be a solar inverter used for that. The second option would be to use DC coupled solar as well. So two different ways that we can get renewable energy back into that battery, DC coupling or AC coupling. We're going to go into a little bit more detail about this, but effectively the difference between DC coupling and AC coupling hardware-wise is simply one is a solar inverter used as a solar MPPT, and the other one is a DC to DC MPPT. When we look at off-grid systems, there's just a couple of subtle little changes, and the fact that we can still use AC coupling, the difference being that we use what's called managed AC coupling, and there will be communications between those two. We'll talk about that in more detail later on. And we've replaced that grid now instead with a backup generator. So we've got the same components, the same elements, if you like, of these systems. We've got our battery inverter, then we've got some form of solar controller, and then we've got some form of backup grid or generator.
So before we move on there, Lindsay, a question's just popped up about explain how DC coupling works with grid-connected system and a feed-in tariff. So if you'd like to go with that one, just...
I was going to say, did we want to maybe cover that when we get to that a little bit more in depth on the DC coupling just coming up?
All right, well, let's cover it then.
Yeah, we'll know that then. Thanks for that question, though. So when we're looking at the capabilities with our AC coupling, let's look at one of the options there, which is a Fronius inverter. And we've got the ability to have up to 5 of these Fronius inverters connected to an SP Pro. So effectively a couple of design rules, no more than 5 pieces on any phase or SP Pro, what we call manager, and no more than 2-to-1 ratio, or for every 2 kilowatts of solar inverter you put on, then 1 kilowatt of SP Pro. So this is when we call it a managed system. And as you can see there, there's an RS485 connection from the SP Pro to the first Fronius, and then from the first Fronius to the subsequent Fronius, we're using the SolarNet, the Fronius SolarNet, which must be hardwired. So maximum 5, and this is what important design rules, maximum of 5 and 2-to-1 ratio for managed AC coupling. When we do the same thing with the new Fimer or ABB inverters, it's exactly the same, and noting that these inverters are connected on the load side of the SP Pro. That allows us then for them to keep operating when the grid should fail. Not that the grid fails very often, of course, he says tongue-in-cheek. The difference with the ABBs here is that we can actually have a wireless situation between each of the ABBs. So we can go SP Pro to the first ABB wireless or wired, and then after that can be wireless also between the subsequent units. Now, in a situation like this, we have to have either ABB or Fronius. You can't have a couple of ABBs and a couple of Fronius, unfortunately. They do talk different language, so it means that the SP Pro can only talk one language. It might be a bidirectional inverter, but it's not bilingual. Does that work, Ivan?
Yeah, that worked.
So important to know as you're approaching your designs there that you have to choose one or the other. There are situations where we can have 2 types, and we'll show you that a little bit later on. So I'm going to throw over to Ivan just for a little bit more detailed explanation of exactly how the managed AC coupling works.
Yep, no, thanks, Lindsay. And there's a couple of questions that come in, which we'll get to those, so thank you. So managed AC coupling, why is that different to the other forms of management? So we need a communication system across to all of the managed AC coupled inverters, and that's so the SP Pro can control exactly how much power each of those inverters is producing. And you can see on the screen here in this example, it's setting the maximum output of the inverter to 81%. Why is that important? So there are a couple of reasons, and it depends on the scenario you're using. If you're in an off-grid situation, you may not actually need that energy at that time. Your batteries may be fully charged or holding at a charge voltage set point, and the loads may be low. So with AC coupled inverters, they will just produce as much as the sun and the panels and the situation will allow. That energy has to go somewhere, and if it's not required, we need a method of turning that down. So we use a communication system across to each of those to manage that, and we can manage it in down to 0.1 steps. Now, using communications means that it doesn't matter whether the generator's connected and setting the frequency of the system, or that the grid is connected, absolutely setting the frequency of the system. We can control the power because we don't use our frequency variation to actually adjust the output power. This means for a grid feed system, we can actually set an export limit. You may have restricted export, and if we're, instead of putting out the full capacity of that AC coupled inverter, which may be beyond your export limit, we can control it and set the export limit so we don't exceed that. But also, if your generator's running, we can, more importantly for off-grid systems, make sure that that energy doesn't backfeed into the generator. backfeeding into the generator is really bad for generators. No, diesel doesn't come out into the tank. That was a joke. Yeah, but it can cause significant damage to alternators and things. But it does mean that when the generator's running and moving in frequency, we can still utilize all of those resources in the systems that we have. So keep going. Yeah, Lindsay?
Sorry, you're finished on that one? Sorry, I thought you had. So along that line, a great question from Mark, and thanks for your question, Mark, about can you have both grid feed and off-grid systems combined with the Pro, and can the Pro manage switchovers, or is other equipment needed? Yes to the first half. The SP Pro is both off-grid and grid feed. It can do both. It's just which way do you wish to configure the inverter. So you might have heard in some of the language there that Ivan used, he talked both off-grid and grid feeding systems. The switchover, we'll certainly cover that later on, but no, that's all done by the SP Pro. And I'll probably at this point push the point that what we try to do is put as much into the box as possible. We know we're not the cheapest, but there's a lot of stuff that you're not going to need extra when you're using our system. So thanks for that question. Thank you, Ivan. So looking at some of the inverters, what we call SCERT or Selectronic certified. So when you're doing your design, what can we be choosing to utilize in these managed AC coupling systems? So we use the Fronius Primo single phase range, which from 3 kilowatts up to 8.2, and the ABB from 3 kilowatts to 6 kilowatts. And just reiterating that design rule, 2-to-1, and that's the AC rating of the inverter. We don't care about how much PV that you're putting into it. You could have 33% or 50%, whatever. Don't care. It's the actual rating of the inverter. So if it's a 3 kilowatt inverter, ABB or Fronius, that's all we're worried about. That can be up to 2 times the continuous rating of the SP Pro, and no more than 5 pieces. So the range that we do, the 3, the 4, the 5 kilowatt international version of the Fronius, the 6 and the 8.2. So we don't do the 3.5 Fronius. Just didn't see a need to be doing so many different versions, so close at the bottom end there. And also it's the international version of the Fronius, not the SC or the superior current version of the unit. So it's the 5 kilowatt unit, not the 4.6 Australian, but it's not the higher current version, the SC. In the ABB range, the 4, the 5, and the 6, but please be aware that the 5 is the new Q Plus version from ABB. That means that it doesn't have an LCD display on it, but it does have a DC isolation switch. Also to note, if you're looking at using that model, is that the second MPPT on the ABB or the Fimer, I have to get into those habits, is only, I think, 11 amps. So the first one is 19 amps, second MPPT is 11 amps. They feel that that's an area that they didn't need to have full current on both MPPTs. So just be aware of that. Eventually we will bring the Q Plus into the 4 kilowatt and the 6 kilowatt, but just the 5 at this stage. Warranties on both the ABB and the Fronius Selectronic certified. It is whatever they are offering. No, we don't alter the warranty in any way, shape or form. So the Fronius at the present is a 5+5 warranty, and the ABB is a 10-year warranty. Let's look at the capabilities that we can take this to in a single phase situation. And using our just recently released Powerchain technology, we've got the ability to put up to 4 SP Pros on the one phase. So as you can see on this graphic here, 4 SP Pros, but we've still got that same design rule of up to 5 Selectronic certified. So what happens once we get more than one inverter in a system, one SP Pro, then one will be called the system manager. So the inverter there that's got the communications line connected to it, that little dotted line. I don't know if you can you see my mouse? Clearly
I certainly can, Lindsay. So
you can, okay, cool. So this is the communications line here, and this here would be the system manager. So effectively you can have a system manager, and as we'll talk later, there'll be a phase manager, but the system manager, it controls 5 of the SCERT inverters. So if we were using a Fronius situation, then if it was a 24 volt system, which we can do, the largest 24 volt system is 4.5 kilowatts. So SP Pro is 4.5 kilowatts. So 4 of those would give us 18 kilowatts. And based on our 2-to-1 ratio, therefore we could have 36 kilowatts of managed PV. Now those 5 SCERTs don't have to be the same model, but the SP Pro must all be the same model. So the SCERTs, you could have an 8.2 and a 6 and a 4, don't care, as long as no more than 5 and it doesn't exceed 2 times the rating of the SP Pros. So 18 to 36, if it's a 48 volt system, our biggest SP Pro is a 7.5 kilowatt at 48 volts. So that gives us 30 kilowatts, but we can't do the 2-to-1. We can't achieve the 2-to-1 in this scenario now because the biggest Fronius is 8.2, so 5 of those is 41 kilowatts. So we've hit the 5 pieces limit before we got to the 2-to-1. And the same if we're using our larger 20 kilowatt units in a 120 volt battery bank, 20 kilowatts by 4, 80 kilowatts, but we've still got that 41 kilowatts of managed PV. So we've got a couple of limitations there, but just depends on what it is you're trying to achieve in that the single phase design. If we're doing the same thing with ABB, then they've got slight different restrictions. It's all the same rules, but because the biggest ABB is a 6 kilowatt unit, 5 times those is 30 kilowatts. So with our 18 kilowatt example at 24 volts, we can't quite get that 2-to-1 ratio because their largest is 6 kilowatts, so 5 of those. So their limitation really in a single phase would be 30 kilowatts of PV in a managed PV situation. Probably not going to be a practical limitation though for single phase. So if we want to look at some of the pros and cons of the 3 different approaches we've just talked about there, in the generic AC coupling, and have to stress that generic AC coupling, that is, there is no communications between the battery inverter, the SP Pro, and the grid inverter. No communications there. As long as it's an AS4777 approved solar inverter, we don't really care brand, size, whatever. So not approved for off-grid operation though, because we don't have that control over the PV. In an off-grid situation, that would be a bit of a disaster to live with. So in this case here, though, we're saying, well, we probably should never really need to turn the PV down because we want it to either run the house, if not, fill the battery, and if it's still got plenty, then it just goes out to the grid. So it's always going to be running flat out, basically. Some of the pros of those systems, well, it means you can add storage to any existing system. So those thousands and thousands of systems that we've got out there in the market space, then they could have storage added to them. So I've just got to turn off my solar powered heating because it's just getting a little bit warm here in the Studio 2 muck. So also it gives you the ability to your choice of solar inverter that you want to have. So some people, for instance, might like to have micro inverters, or they might like a particular brand of inverter, or it might just simply be that that's what's already installed. So that's what you sort of got. You don't have to worry about comms to those 2 inverters. So a little bit less to do there when you've got a generic AC coupled inverter. But what about some of the cons? Well, it does mean because we don't have control, it's only a 1-to-1 ratio. Now we've been talking about this 2-to-1 ratio with the managed AC coupling, but in a generic, it's only 1-to-1. And the reason for that is simply it's about speed of controlling the output. Should there be, say, a break in the grid or dropping of the grid, then the SP Pro has to manage that energy. It's about speed as one of the big issues. Would you like to add anything to that, Ivan? I know we had that point yesterday. Did you want to elaborate on that point?
Yeah, so really it's about the SP Pro has to be able to sync all of that energy that's coming from the unmanaged system. And that's why there's the 1-to-1 ratio. You could imagine if there was more power there than the SP Pro was rated to deal with, the SP Pro wouldn't be damaged, but it'd certainly shut down and you wouldn't have the backup function that your customer has paid for. So key thing here has to be power ratio 1-to-1, and that's why there's that change.
So giving ourselves plenty of headroom there so that we won't get those problems. So that means that it may be for a given size of array, you may have to have more SP Pro. So that could push the cost of the system up a little bit. Also in a generic AC coupled system, because we have no control over that solar, then we can't do any export limiting. It would be something if it was an existing retrofit system then, and there was some export limit required, then that would be already taken care of by external equipment. So we shouldn't have to worry about that. The other important thing to consider is that because, again, there is no communications, the SP Pro has no way of knowing how much solar is actually being produced. And because the solar is AC coupled in this example and going straight into the load, that means that the SP Pro also will see an inaccurate load data number as well. So if you're using any monitoring on this, excuse me, using any monitoring, then it may be a little bit disappointing for the customer that they don't get those two pieces of data. The state of charge of the battery will always be correct, however, because the only way that anything can get in or out of that battery is through the SP Pro, whether it be from the grid going into the battery or from the AC coupled PV going into the battery. It's going to go through the SP Pro, and then again, anything coming out of the battery, whether it be going to the grid or going to the load, will have to go through the SP Pro so it can then count the state of charge.
Yeah. And just before we move on there, and because this is a key difference with the generic, and Steve Sanger has put a little question in the chat. Could I ask that all questions go into the Q&A? I only just noticed your question, Steve, but thank you for your question. Please put them into the Q&A. But the question was, what happens when there is a grid outage and the power isn't required that's being produced from the generic inverter? And the answer is that the SP Pro will automatically push its output frequency up, and the grid inverter, the generic grid inverter, will then see that as the grid going out of tolerance and disconnect. So we frequency ramp, turn off any grid connected inverters that are on our load side, and in that way we have some very coarse control, very on-off control of the power, protecting the battery system, but while still maintaining power supply through to the house. So that will only happen if the batteries are full and there is no load required. The load that's being consumed isn't taking everything from the grid connected inverter. It will ramp the frequency to drop that energy off. So thanks for your question.
Thanks, Ivan. So AC coupling generic, we do really recommend that this is where you're retrofitting. This is where you would use this. It's got a couple of I guess negatives against it, but it's got some positives. But it's something we expect that it really has to be for a retrofit system. Managed AC coupling system. This is where we introduce the Selectronic certified, and we have communications between the Pro and the solar inverter. We see a bit of a list of positives there. Pros: no frequency shifting at all in the home, whether that be when the grid is there. Of course, we can't frequency shift when the grid is there anyway, or when the grid has gone down, no problems. It's still rock solid 50 hertz because we use that communication. And because we have that nice fine granular control of the solar, then we're going to get nice precise battery charging. We have seen over the years issues with batteries not being fully charged using methods other than what we're doing, which may be a bit more coarse, and that has led to early failure of batteries. And what we're trying to do here is make sure that these systems are going to be reliable and reliable for as many years as possible. And when we talk years, we're talking 15, 20 years, not 5 and 7. Full data visibility now that we've got communications. So looking at our app or whatever, we'll see exactly what the PV is doing. The load will be accurate. Everything will be happy there. And the fact that we can now have a 2-to-1 ratio on that PV. So if we've got an 8.2, or let's just say we've got 2.5 kilowatt Fronius there, 10 kilowatts, that means we only have to have a 5 kilowatt SP Pro. Whereas if that was 10 kilowatts of generic AC coupled, we would have to have 10 kilowatts of SP Pro, which I'm quite happy for you to do, because that does make my sales look better, but might not be the best for you winning the job. So there are some real benefits there. And this can be off-grid or on-grid. So if the customer's saying, look, maybe one day I'd like to perhaps disconnect the grid because they've got a nice big house or a big property that can have lots of solar on it, then it's no problems. It really is a case of just coming along, reconfiguring the SP Pro, and you're a complete, proper, thoroughly original off-grid system. When we talk off-grid, we mean it is off-grid, not just we'll back up for an hour. And there's a lot of poor language being used in the marketplace at the moment about what actually off-grid is. We mean off-grid 24/7 for years and years and years. And the SP Pro can also, in this situation, can be used as the export limiter. And I'll show you a little bit more reasons exactly why for that later on. Some of the negatives to managed AC coupling, yes, you're going to have to get communications between the SP Pro and the solar inverter. Can't get around that. That's something you have to do. It will be a little bit more expensive, but if we're going to be getting perhaps longer life out of batteries or getting a way better experience for the consumer, then we believe that that expense probably is not too much of a burden in the right situation. And yes, you will have less choice of the solar inverters. You've got the Fronius and the ABB. They're the two choices that we have. I guess in terms of if we had a magical crystal ball, which would we like to add to that? Well, SMA is a popular inverter, of course, but we are friendly competitors, so that's probably not commercially practical. Maybe N-phase might be one that would be nice to add to that, but at the moment we've just got those two inverters. Looking at DC coupling, a couple of the pros and cons, and I'll get Ivan to answer Andrew's question when I'm finished on this slide here. But DC coupling meaning that we can now have unlimited PV because it's not restricted by the size of the SP Pro, because that DC coupling, that solar controller, is going to do all of that conversion process. So it's really would be probably more limited by the battery itself. The other thing is that if the SP Pro should be turned off for any purpose, for any reason at all, then the DC coupling will still continue to charge the batteries. It's an interesting topic, that one, and it's a topic we could probably talk about for 15 minutes on its own. So we won't do that here now, but let's just say that the DC coupling will continue to go charge into the battery when the SP Pro is turned off. And another really important point for on-grid situations is that you'll find a lot of utilities will suggest you have a 10 kilowatt inverter capacity. And an MPPT, DC coupled solar, is not considered as an inverter, therefore it will not be added in, excuse me, won't be added into that, that number. So you could put unlimited DC coupled PV on a system that otherwise may not be able to have any more than maybe 5 kilowatts of PV. So Ivan, would you like to answer Andrew's question there, please, mate, while I clear my throat?
Yeah, absolutely. So thanks for waiting, Andrew. So the way DC coupling works, you can see there's the shunt on the screen. So the SP Pro can measure the amount of current coming from the DC coupling. And of course, the SP Pro is measuring the battery volts. So the way the system can work, and there are a number of different modes. If the AC source was the grid, obviously, the SP Pro can detect how much current's coming in from the DC coupling and effectively draw that current from the DC system and push that out to the grid and the house loads. So it's really quite straightforward. We can measure the current flowing in, so we can pull that current and only that current from the DC coupled solar and push that and export that out to the grid. So in that way, you'll be getting export and your feed-in tariff will be feeding through. Yeah, it just works like any other grid feed system.
Thank you, Ivan. And Bruce from New Zealand is asking, what is the maximum distance of the Cat5 between SP Pro and PV grid inverter? I think 485 is 100 meters. Ivan, is that correct?
Well, we stipulate 100 meters. RS485 strictly can go 1.2 kilometers, but there are very special cable requirements and speed limitations and so on. So as a rule of thumb where you'll get no problems, stick to the 100 meters between the SP Pro and the AC coupled inverters.
Do we have the ability, Ivan, with a Fronius system, because it uses the solar net after the first Fronius, it has a rating of much longer for those subsequent inverters? Is that correct, or is that misleading?
Yes, it is. So the solar net cabling is runs a slightly different protocol, and the solar net will run up to 1 kilometre on its cabling. You will have to, however, it still actually has to be specialised cable. It's not your standard Cat5 type cables. It's all to do with the way the cabling's made. So if you do wish to use the SolarNet cable and extend at that, just check all the appropriate specifications in the Fronius manuals for exactly the type of cabling you'd need to reliably achieve that extra distance on the solar net.
Thank you, Ivan. Moving on to a couple of the cons then of DC coupling. This can't be used with a managed battery. So a managed battery being something that requires a communications cable between the SP Pro and the battery. So you can't use that with DC coupling. It is likely to be a little bit more expensive for some of the larger arrays. We find that a lot of the systems that are going in these days are around sort of 6 kilowatts minimum PV. That's what we're getting involved in. So that would mean probably 2 MPPTs. Most of the MPPTs are about 3 kilowatts. So a couple of those. Also, depending on which MPPT you use, some of them are 150 volts range. Some of them are up to 600 volts. So if you're using certainly the more cost-effective, smaller ones, which are 150 volts, then you'll have to have more parallel strings on your PV. So that could be a little bit more expensive, and you will require a current shunt on the output of that MPPT so that that can be read by the SP Pro to calculate the state of charge properly. So a couple of pros and cons of DC coupling, but don't ignore it. If you're wondering what the MPPT is in that picture, it's the Australian-made AERL. And a little bit like us, AERL actually were the first company, I think, in the world to develop maximum power point tracking. Look into the history books, you'll find Australia has been at the forefront of that. So also a second generation company, so it's nice to see. What about if you're going to a site though, grid connected again, and you've already got a Fronius installed or an ABB, but it is not a Selectronic certified, then it is certainly possible. Take it off the wall, send it back to us, and it can be upgraded to a Selectronic certified. It's a chargeable service, of course. We don't do that for nothing, but it could be a lot cheaper than perhaps having to put bigger SP Pros in to accommodate the size of the PV, because even though it's a Fronius, if it's not Selectronic certified, it must be dealt with as generic AC coupling, therefore 1-to-1 ratio for PV and SP Pro. So that's something that we certainly offer that on the Fronius range. And even though we don't sell the SC version of Fronius as a standard, then you can certainly get that upgraded as well if you wish to send that back to us. Let's talk about some multi-phase systems now utilizing our newly released Powerchain technology. So it's now possible in single phase systems, 3 kilowatts up to 80 kilowatts. Dual phase, we can go from 6 to 160 kilowatts, and in 3 phase, 9 to 240. So what we're doing is the SP Pro is a single phase inverter, and we will synchronize it together to create dual phase and 3 phase. We'll show you a bit more about that in just a moment. In fact, that moment is here now. So we get a lot of call for dual phase systems on grid. They seem to be a lot more popular than we realized in the beginning, but we've successfully handled those. Simply 2 SP Pros would be installed, 1 on each phase, and these can be 180 degrees separated, of course. It's just a case of programming the system that way or configuring the SP Pros in the way, and you'd be using single phase Selectronic certified inverters on each phase. What will happen, there'll be a sync cable or a synchronization cable, data cable, which is supplied with the SP Pros, goes between each of the SP Pros. So that SP Pro on L1 will be called the System Manager, and the SP Pro on phase 2 will be called the Phase Manager. And you'll see a little bit more about why we do that, why we say that. Same situation as the rules, 5 pieces of SCERT on each phase, because this here is a System Manager, that's a Phase Manager. So now we can say to 5 SP Pros on each manager. So we could have 5 ABBs hanging off here, or Fronius, and 5 hanging off here, as long as we don't exceed our 2-to-1 ratios. So if this is a 7.5 kilowatt SP Pro, then we can have up to 15 kilowatts here, and these would have to be both the same model. So another 7.5, another 15 there. There will be minimum battery requirements, but we'll talk about that a little bit later. Then we want to generate a 3-phase system, and basically we're just going to do the same as what we had before, but we're adding a 3rd SP Pro to it. And again, we'll use those sync cables supplied to generate now 120 degrees proper 3-phase. So we can run 3-phase loads. It's not just 3 phases, but it is actually proper 3-phase output. We use a common battery bank in these multi-phase inverters or multiple inverters, and that means that we can share energy between the phases. So if you've got one phase which has just got lots and lots of excess PV, that can be effectively being used by the other phase which might be lacking in PV. So a couple of questions we need to answer there, Ive.
Just one, the one that's pertinent right now. So Stephen Sangster has asked, dual phase, can we cater for properties? They've only got two phases coming in, but they're 120 degrees apart, not the 180 degrees apart. So they've obviously got the normal street feed and they're just pulling two phases off the three-phase street feed. And the answer is absolutely yes. In this diagram you've seen there with three phases, you only have two of them and you configure it for 120 degrees instead of 180 degrees. So absolutely, we can certainly do that. And Romy's asked a question about lithium-ion batteries and managed. We'll cover that a little bit later. Thank you.
Thanks, Ive. So if we we've also got the ability with the three-phase systems, we can use one of two different inverters for Selectronic certified. We can use the Fronius Simo range now. And I'm just looking back at the previous slide. I didn't mention the fact that we introduced at this point our Select Sun three-phase grid inverter. So instead of using multiples of the single-phase solar inverters, we would use a three-phase Select Sun inverter, or we could also be using the Fronius Simo range of inverters. And I'll show you which ones that we actually deal with there. So the capabilities that we've got here in the biggest systems possible is that by using, say, our 20 kilowatt units, which would be a 120 volt battery bank, we've got up to 240 kilowatts, 4 per phase. And then that allows us to put up to 5 of the Selectronic certifieds per phase manager. But in this case, we actually hit our 2-to-1 limit of 480 kilowatts with 4 of the 40 kilowatt Select Suns. But if we were using multiples of something else, then we may be able to get to 5. But still the same rules apply, even though this looks a much bigger system, the same basic rules again. The nice thing about having different phase managers is it allows us to have, say, Fronius on one phase manager and the Select Suns on another phase manager. The Select Sun is a higher powered inverter, but it does, because it's aimed at the bigger systems, it only has a single MPPT. So if you wanted to maybe, if you've got a lot of different roofs to be dealing with, then you might use the Fronius with the two.
Sorry to interrupt you there, Lindsay. Can you just check the position of your microphone? I think people might be finding it difficult to hear you.
That's strange. It hasn't
That's
changed.
Sounding much better, thank you.
Okay, well, we might better hold that up there. Sorry about that, folks. So with the Powerchain, it gives us the ability to have both Fronius and Select Sun. So we can't have a mix on the same phase manager, but you can, where L1 phase manager, it will be talking Fronius language, L2 will be talking Fronius in this slide, and L3 would be talking Select Sun. So it gives us quite a bit of flexibility there where you might have some shading issues. The inverters that we've got as options for Selectronic certified in a three-phase from the 8.2 to the 15 kilowatt Simos. So we don't do the 17.5s and the 20s at the moment, but when we get into that size, that's where we use our Select Sun 20 kilowatt and 40 kilowatt. So having a quick look at the specs here, I don't expect you to have to read all of these, but it just gives you a little bit of an idea of what's possible there. So it's a single MPPT on those 20s and 40s, and the Fronius is the dual MPPTs. Really important, just really want to drive this point home because it amazes us. We do get this question quite a lot. When there is an outage, a grid outage, then any solar which is connected to the load or to the output terminal of the SP Pro will continue to operate as normal. Put simply, a grid inverter is looking for a grid. It still sees the grid, it just happens to be totally formed by the SP Pro and the battery system when the grid has gone out. So all three sources, grid or generator, battery inverter, and solar inverter are all running together. They're all synchronized together. Want to really make sure that everyone has a good understanding of what we mean by power. Now, already I've used some terms repeatedly when I say, what about the 7.5 kilowatt SP Pro? What does that mean? Now, you might think, oh, hang on, he's going to low level here. Well, no, because so many people are getting this wrong. And it's unfortunately maybe the fact that there is no standard on how to rate inverters. Now, when we talk about 7.5 kilowatt SP Pro or a 3 kilowatt SP Pro, that means It is 24/7 at 25 degrees. It will run that continuously. Not to be confused with the 30-minute output. Now, all of our friendly competitors will all rate their inverters at 30-minute output. You'll see the continuous output in the data sheet, but you will have to go looking for it. So if they suggest, and this is no slur intended on any of the products, just the way they're presented, a Sunny Island 8 is a 6.4 kilowatt continuous inverter. So you wouldn't want to be comparing that with perhaps with our 7.5. You'd actually be looking at our half-hour rating. So on a SPMC 481, which is our second most popular inverter, it's 7 kilowatts for half an hour, or our SPMC 482, which is 7.5 kilowatts continuous, it's 11.25 kilowatts for half an hour. So it's really important that you do understand that, because it can be easily thinking, oh, no, that's too expensive to go that way, but let's look at the dollars per watt. You'll see the peak outputs there as well, which are going to be very important for when you're trying to design something where we've got a pump or something starting, and we need to know, can we get that pump kicked away, particularly when the grid fails or if it's in an off-grid situation. But I think the real measure, and I've changed my tune on this quite a bit, is instead of looking at dollars per watt, let's look at dollars per charge amps. Now, it seems to be, and this is just my own theory on this, but it seems to be that manufacturers are saying, well, an inverter probably isn't going to be pushed to its maximum continuous rated for very long. So that's why they use the half-hour rating. But when you're charging the battery, that's when you do, likely it could be a boat situation, or it could be AC coupling, where you're going to be running the charging for many, many hours. So that tends to be a truer indication of its real continuous power. What's the engine capable of? So over in that right-hand column, you'll see continuous charge power, and it's exactly the same as the continuous output power. So that first line there, the SPMC 240, just because it's easier to see, 3 kilowatt inverter, it's a 3 kilowatt charger as well, because it's a bidirectional inverter, so there's no reason for it not to be. And when you do basic Ohm's law, you'll find that that's 125 amps. Now that is a minimum depending on the temperature. We had a great question yesterday about a guy saying, I keep seeing more than the recommended or the specified charge current. That's because it was a cooler climate and the temperature of the SP Pro hadn't warmed up, so it was a little bit higher than the numbers that we're seeing here. These are at 25 degrees as a sort of a minimum. So look at the charge current of an inverter and then compare that. So looking at dollars per charge amp, I think is actually a better way to compare some of these inverters. And as I said, in this market segment, I think actually we're the only ones that are using the continuous rating when we talk about inverters. It doesn't mean there's anything wrong with that, it's just understanding so you can compare apples with apples. Another question that comes up quite regularly, and just to try and understand how we achieve that, we use 50 hertz technology. That means that what you see on the left there is our transformer. It's big, it's heavy. So when you're installing these, and you're going, bloody hell, these things are heavy, that's where all the weight comes from. There's a lot of copper and iron in these toroidal transformers. But what they do is, because there's so much mass in there, they take a long time to heat up. And that means that we can be running them at more power output until they heat up, and then we can start to back it off a bit. On the right-hand side there, that is the equivalent in sort of high-frequency transformers. Again, nothing wrong with this. It's just understanding. So this here would be typically maybe your 5 kilowatt style ETD type transformer. Quite a bit different from this transformer over on the left. But the differences would be that if we're to take a 5 kilowatt transformer based inverter or 50 hertz transformer, then its 5 kilowatt peak output, or in our case, will be about 2.4 times. So it's about 12 kilowatts of output, whereas on the right, that same unit rated at 5 kilowatts continuous, but with a 20 kilohertz transformer, which is much lighter and much smaller, but it has no thermal mass in there, so its peak output will be 5 kilowatts. So if we're looking for something that's going to maybe be able to handle suddenly some loads going on, I know at my own place here, maybe I'm a bit of a wanker because I've added a spa and a swimming pool and we've got some heating and things in here now, but I'm actually seeing some peaks, say for instance at 1 o'clock in the afternoon when the spa kicks in and does some sort of a cleansing cycle or whatever, and I'm running at about 6.5 kilowatts for about 8-9 minutes. Now that would shut down that inverter on the right-hand side, or that high frequency inverter, whereas my inverter, which at the moment I'm using a couple of the 3.5s, easy done. So no problems in handling a lot of peak loads because of that big transformer. Yes, the weight is a killer. Inside, you are going to see that we have a transfer contactor transferring the AC through to the load. We use a contactor, not a relay, and that we believe is done, well, we know it's done because we see a contactor as being significantly more heavy duty, but it's powered by the AC source, which means, as you'll see in a minute, I think, that the AC source, if it's there, that contactor can always be pulled in regardless of what's happening to the inverter. Whereas if something is DC powered, if we lose a battery or something like that, then we may be turning the lights out to the system. Now that contactor is rated quite highly. So all of the smaller inverters up to 7.5 kilowatts have a 63 amp contactor. Looking at that middle column there, standard AC transfer contactor, 63 amps. The two larger inverters are 125 amps. The extra contactor, sorry, I lost my point there. The contactor which we can put on them, if we want to, is up to 1,000 amps with an external contactor. So 63 amps is standard, or 125 amps is standard, and then up to 1,000 amps as an optional extra. So it gives us a lot of ability to pass through a lot of current from the grid. Let's have a look at that. So what we're going to do now is just add in what actually is inside there. I've kept it out of the drawings up to now just to keep everything simpler to see, but inside there's our contactor, and there's also two CTs inside there as well. So our AC source, grid or generator, is coming through to that contactor. That will be measured by that CT, so we know what's coming from the generator or the grid or going to the grid, and the same on the output side of things. And this is, of course, where we get our anti-islanding. But it allows us then, because of the generous ratings of that contactor, it allows us to back up the whole house. We don't sort of really subscribe so much about, oh, let's just pick one little baby circuit and back it up. What if you've got lots of PV, and we know that there's more and more PV being installed these days? So let's utilize it. If there is an outage, then why not utilize that if it's there? But it is possible that we could add some discretionary load control. We still take it off that output side of the SP Pro, and that could be controlled by the Pro to say, okay, well, if the grid has failed and the batteries get down to this state of charge, then turn these loads off. We can control that without a problem. The typical changeover time or transition time that we prefer to call it between when the grid fails is about 30 milliseconds. So probably blink of an eye. Is it going to keep up computers, etc., is what people ask. Yes, that shouldn't be a problem, but if it's a critical situation, we would suggest you still put a small UPS on that computer. But as I mentioned in the previous slide, if we do lose a battery or lose the inverter for any reason, if the AC source is there, that will actually pull that contactor in and continue to power the loads. So static bypasses, as we often call it, is what we're achieving there. For an extended outage type of situation, it may be required that an auto start generator is installed as well. So for rural blocks where you're looking to maybe have days with no power, then we can't generally put a battery bank in big enough. So putting an auto start as a backup. Really important to realize, though, we're not just going to start the generator just because the grid's failed, because again, you've got battery storage energy there, you've got PV potentially. We don't need to. So what we've really done as soon as that grid fails is we are now going into off-grid mode. We're operating just like off-grid. We'll start the generator when the system needs it. You will be required to install what we call a grid fail generator backup module inside each SP Pro in the system, and that will control that auto start generator. It has to be an auto start generator because we're constantly monitoring the grid, of course, to know when it comes back on so that we can turn generators off if the grid should come back on. It's not suitable at this stage for 120 volt. We only have a 24 and a 48 volt grid fail generator backup module, but you will not require this module for off grid. So effectively the SP Pro has one AC source input, whether that be grid or generator, that's all standard. But if you want two, grid and generator, then that's when you will install it. So it gives us a good bit of flexibility. And as I said, it's a tight fit inside the Pro, but it does certainly fit, and it saves you a lot of mucking about in timers and various other bits and pieces. Should add at this point, full generator control is standard part of the Pro. You don't have to have any extra modules if you are just using it for off-grid. It's all standard inside the SP Pro. Question comes up very, very regularly about batteries. Well, there's two different types of battery, just like solar, where we've been talking about generic, which is effectively unmanaged solar inverters, or managed, then batteries are exactly the same. An unmanaged battery is a battery that does not require any communications between the battery inverter and the SP Pro. So as long as that battery that you're thinking about using is within the voltage range of the SP Pro, then it can be used. We don't care whether that's lead acid or lithium or whatever. So popular in the market space at the moment, for instance, is to use maybe Gen Z lithium, which is an unmanaged lithium, or Power Plus Energy as well, Hitachi lead carbons and Acult lead carbons, and a couple of the lead acid BAE and Sonashine. They're all unmanaged batteries, don't require any comms, and they can be used as is. If there's another brand that's not listed there, or it's a new brand, ask the battery supplier, say, well, can you confirm that your charging requirements are within the voltage ranges of the SP Pro? And SP Link is a good way of using that, which is our configuration tool. It will show you the ranges that we can charge at. A managed battery is when we introduce communications, and this goes down to a little bit more detail, where the battery becomes a little bit smarter and starts to tell the SP Pro, right, yeah, normally just charge me at this rate, but because I'm too hot, too cold, or for whatever reason, I need you to back me off a little bit. And some of the examples of that would be BYD, Pylantec, LG Chem, both the Resu LG Chem and the rack mount standalone modules that they use for their bigger systems, which is what I've got here, and the Sonashine lithium at home as well. So they're a managed battery, and they must be an approved battery. You can't just decide that you'd like to use one of these, a battery that needs comms one day. It does need to be approved by both the inverter supplier and the battery supplier. It needs to be a declaration made by the battery supplier as well. So it is actually a process. So they're the 4 batteries that we are dealing with at the moment. I've been waffling a bit there. Is there a couple of questions?
A couple of questions, and you've stopped at the perfect time. Thanks, Romy, for your patience. So we're talking about managed batteries, and that was your question from earlier. Can you use DC coupling and AC coupling with managed batteries? So with managed batteries, we have to get approval for the whole system from the battery company. So our whole system works together. Currently, only AC coupled systems are approved with the managed batteries. So if you have managed batteries, you would not be able to use DC coupling with them. And there are a couple of other questions regarding the generator, the grid fail generator backup control. So Mark has asked, can we still manually control the generator if you wish to in that situation? Yes, absolutely you can. The generator is still an auto start, auto control generator. And if you want to use the generator, you can simply drop the grid out and press the start button on the front of the SP Pro, and the generator will automatically start and run. We do not recommend a manual start generator in these situations. And the reason behind that is one, the client doesn't actually know when the generator is required. So maybe they'll turn it on at the right time, but then because there's no monitoring of the grid or anything, they don't actually know when to turn it off. So it really is a poor system in terms of the managing your generator in those situations.
Just if I could add something to that, please. We certainly did used to allow a manual start, and it created problems, not in terms of SP Pros failing, I think, but it was just such a dog's breakfast from, the customer wasn't home, so they couldn't start it. The difference between an auto start and a manual generator is maybe $1,000. We believe that the benefits over that, making that automatic, is just far outweighs the problems that you are likely to get as callbacks to say, yeah, I forgot, or I thought it was going to be sunny tomorrow, so I didn't start, and all those sorts of things. So really best, we'd suggest to stay away from it.
Yep. And Bruce has asked a question about what are the requirements for digital signals for secondary AC supply and so on. Everything is built into the SP Pro. So in terms of what you need to provide to signal the SP Pro, it's all part of the SP Pro in the grid fail generator backup kit. You simply wire both the generator and the grid into the optional kit that we install, and the SP Pro looks after the rest. So there's actually nothing further to be done there. Thank you for that. And the other
Neil's
question,
asked us, sorry.
That's right.
Neil's asked us a question about LG Chem and BYD on the same SP Pro. No. So we use a common battery bank. But whilst I don't think we have actually tested that, I think I'll go out on a limb here and just say no. One or the other.
No is a definite no, because like the Fronius and the ABB units that don't talk the same language, LG Chem and BYD on their communications are also not the same. So no, you definitely could not do that.
I'll just jump. Can we use one generator be used across two SP Pros from Andrew? So if the SP Pros, generally what you'll have, depending if it's a dual phase system or a three-phase system, we do get the question asked about what about a dual phase system, and I just want to have the one generator. It gets really quite messy because we tell the SP Pro what size that the generator is, and the manager of the system, the SP Pro manager, it will then take care of that. So yes, you'll effectively be putting the generator across the two, but it will just be started by the master in the system, the SP Pro master, because it will then take care of loading that generator up to its specifications. So we don't want to be just having a random load of however many SP Pros on there. So it will go to all the SP Pros if they're all in the same phase, or if the three-phase generator, it will go to all SP Pros. Perhaps a little bit more detail on that one than we've got the time for today. But if you want to contact us, please feel free, and we'll go through that in a bit more detail as to exactly what you're looking for there. Another one there, Ive?
Oh, I think we're just pushing a little for time, so I think we'll keep moving and we'll cover those questions right at the end. Thank you.
Okay. We get also a lot of questions about, I've designed a system, it needs the 120 volt system, but I can't find an appropriate battery. Power Plus Energy, which are an Australian or Melbourne assembled battery, they are doing a 120 volt lithium. That's been out since about December this year, and it's an unmanaged battery, so it has no comms required. It's just been working quite nicely. So you can use that there. It will eventually, I think next month, it will become what we call a supported battery. So it will be in our drop-down menu in the SP Link wizard, where you'll just be able to choose it as a battery. Whilst it's not managed, it will though pre-populate all the approved settings. Hitachi lead carbon has been used on a few of these bigger 120 volts, and BAE lead acid has been used on the two largest systems that we've been involved with in the last 6 months, 9 months actually, both BAE systems in that one, 1.2 megawatts and about 900 kilowatt hours of battery storage. A bit of a warning though on choosing batteries. You need to make sure that if you want the full performance out of the SP Pro, then make sure that the battery can deliver all of the current that it's going to need. Sometime you are going to find you'll have to go up in terms of storage, more kilowatt hours to be able to actually get the current that the SP Pro needs. So there's no point in, say, for instance, putting a 7.5 kilowatt SP Pro, which can peak at 18 kilowatts, on a 6.5 kilowatt hour LG Chem Resu. Great little battery, but it's got a 5 kilowatt maximum output. So the chances are you're going to overload that battery, and that will shut down the system, black out the site. We don't obviously want that. But be very mindful that managed batteries, so comms, LG Chem, BYD, Pylon-Tech, they have a variable output, if you like, because they've got comms. This is how their price comes down, is they know they can pull back the system at any given moment. So let's say they suddenly feel like they're getting stressed, or they lose some cells internally, or whatever they do, then they can tell the SP Pro, yes, I know I was telling you before to take so many amps out of me, but now I've changed my mind. Take half of that out, or whatever. So it is a dynamic number. So if you do your system design on a managed battery, don't push it right to the edge. You're going to have to give yourself a bit of headroom for those variations. Classic situation, cold morning like what we've got here in Melbourne, but beautiful and sunny. But the battery is saying, no, I know you've got more current you can put into me, but I can't take it because I'm too cold. Therefore, it will have to back off that PV charging. And another consideration is for batteries being offered to you, just look at what voltage range that they need to be able to extract the energy that they're offering you. So if a battery is saying, yes, we can offer you this much of deliverable energy, but it's from, say, 40 volts to 70 volts, well, the inverter that you're using, the battery inverter, what will it do down below nominal voltage? Generally speaking, a transformer-based inverter, whether it be ours, Victron, SMA, generally speaking, they're designed to hang on down below their nominal voltage, so 48 volts, and hang on as opposed to give you full performance output down to that. Because it's a transformer with turns ratios of X, then they'll normally maximize that for nominal voltage plus 20, 30%, something like that. And this is where our SP-Link wizard really becomes your friend. I use this all day, and so do the other design guys in our team, where people will say, well, how many BYD batteries do I need for this configuration here? Just open up SP-Link. The wizard comes up first, and then just put the numbers in, and it will tell you how many batteries that you need. And it's something we are in cahoots with all the battery manufacturers, making sure that that will fulfill their warranty requirements. So SP-Link, let it be your friend. It's not just a at time of install configuration tool.
So just on that point, there was a question there, Lindsay, and from Nick, who was asking exactly that. So yes, as you mentioned before, we're putting more and more batteries into the Quick Start wizard. And as Lindsay suggested, the Power Plus are certainly coming in the next month. So that certainly helps out with making all the settings as simple as possible for you all.
So effectively, there'll be two types of batteries. There'll be a managed battery, as we know now, and a supported battery. So Gen Z, for instance, they are not managed, but they are supported. They're already in our wizard, and that then just makes it easier for you to pre-populate all the charging fields, etc. So, yep, we're working towards that. We should answer Bruce's question there. What battery type selection for non-managed battery? Well, we've got that would be custom style then, and there is a lead acid setting, and there is a lithium setting. I think there's another setting there, Ivan, but basically what you're really needing to do is their starting points when you choose, say, lithium from the custom battery type, it will put in a starting point of battery charging configurations, but you will need to confirm with your battery supplier, right, you tell me how you want your battery charged for compliance with your warranty. So it really almost it becomes a battery manufacturer's question. Are we compatible with Tesla battery storage? Well, the Tesla battery is a high voltage battery. And so our highest voltage is 120 volt. In a bespoke type of design, we have done something similar, but we actually found that it was actually that complicated that it was best to not bother. Happy to take that one offline, but it was quite complicated when we tried to do it. It really didn't achieve what the customer wanted in the end. Select Live, I'll answer, I see Stan's question there. Select Live is the monitoring portal, and apologies, we're a few minutes over time, but it looks like everyone's hanging on there, so thank you for that. The monitoring is done by Select Live, which is a little box that will sit next to the system manager. So you only need one of these per phase, per system. You don't need one on every phase or every SP Pro, just one per system. It's Wi-Fi or Ethernet, that little box, so you can get to it wirelessly or with wired. Uses any browser. As long as you've got a browser, then you're going to be able to see like what you see on the right-hand side of the screen there. The latest addition, though, which is really, really cool, is that once you have this installed, then it allows you as an installer or as a system designer to access the system using SP-Link. So again, wherever you have your SP-Link, that does require a Windows-based platform, then you'll be able to access the system. So that means you could do a download, maybe to do some reports for the customer to show them how the system's operating, or it could be to maybe make a tweak to the system in configuration, maybe look at some fault finding, but SP-Link is the tool for the installers, and we see Select Live as more of the tool for the end users. We deliberately made Select Live reasonably simple because we think that things like state of charge are really the main things that people want to know, and those little dots will move, telling you whether there's energy coming from the grid or to the grid. The grid will change red or green depending on exporting or importing. And you can see at the touch of any of those icons how much energy has come from them today, for the week, for the month, and for the year. So it's deliberately tailored to suit end users, but also not to put that much information there that your phone is just going to keep ringing with people saying, oh, well, at 4 o'clock, the battery voltage was 58, but just an hour later, after the sun's gone down, in Melbourne in winter anyway, now they're 52. What's wrong? So we've tried to avoid that. Keep in mind, though, as we mentioned earlier on, that generic AC coupling will miss the solar data in this, and also the load data during the sunshine hours will not be accurate. So that's something please be mindful of. We don't want people being unhappy about that. Just a quick view of SP-Link, the configuration tool. So it's got many aspects to this tool. You'd use it for configuring at time of install. You use it for doing downloads, to do system analysis, for performance. There's lots of information there, and that's all accessible once you have Select Live installed. All right, so it's starting to wrap up. Questions that we should ask at the moment, answer at the moment, Ivan, or keep going?
So there was just one I thought was appropriate, couple at the moment in regard to Select Live. And the first one from Stan again was, what restrictions are there on Wi-Fi connectivity using Select Live? There's the Select Live uses 2.4 gig. It doesn't support 5 gig Wi-Fi connection. So as long as you've got a 2.4 gig Wi-Fi connection in range, there is no other restrictions on that. So thank you for that one. Steve Dart in WA, thank you. Good to hear from you. Does Select Live work on LAN only installations? Now I'm suggesting there that there's no internet from your question. No, you must have an internet connection to get back to our server. It won't work without a internet connection. In terms of poor satellite, I've personally tested the Select Live across the SkyMaster NBN satellite through many remote places, and it certainly works quite reliably through that. If the service is worse than SkyMaster, I know we're getting into realms of political debate here on NBN, then that's not going to work for you. But I've certainly had it through to some very remote parts of Australia using the NBN satellite. So thanks for your question there, Steve.
And Nick has asked a question, which is a really interesting question. Are we likely to see Select Live have the option to remote start generators, etc.? And this is going to be an app. An app is something that is suggested for the future. We've just got a few other things to get done through R&D at the moment. So that is something in the product roadmap considerations. But starting a generator, it's an interesting one, and we've had some robust discussions on that one, because why should the customer be making decisions about starting a generator? If they can turn it on, they can also turn it off. And we get a lot of phone calls to our tech support department where every day the generator starts, And 9 times out of 10, we find that that's been because the SP Pro has had to do something, such as equalize a set of lead acids, for instance. But the customer didn't understand why the generator was on, so he turned it off. The next day, like a good little SP Pro, it said, well, I still haven't done as I've been told to do. I'm going to do it again. So it creates some real potential problems with having that ability. Now, maybe it's something we need to do under perhaps another layer of security, but it's certainly something we are considering. Select Live has got so much potential that we're just exploring at the moment. So I hope that answers that question without a definitive, Nick, but that's certainly in our thinking. Okay, so Bruce wants us to email him. Why did you want us to email you, Bruce?
That's all right. We'll sort that out.
2 parts to that. All right. As a bit of a conclusion and a wrap up, thinking about your system approach here, the price or the value of systems, I mean, really, what is it that we're looking for here? Do we just want cheap price, or are we looking for something that we're saying, well, over a 10-year, 15-year period, then the cost of owning this system was a lot lower than if I had gone to cheap? It's the old argument, of course. We're trying to look at the value chain proposition. That's really, to us, is the most important thing. We know that we're not in the 95% market share, and nor are we really trying to be in some ways. But that's why Selectronic have the name that it's got. So we just thought we'd go through a few of the benefits that we see from a customer point of view. we're talking 15 to 20 years of inverter life, not 5 or 6. And that's something that's proven. It's not just talk. What I mean by that is that we can show you inverters that we've got out there, SP Pros, for instance, 11 years old. Now, they're the puppies in our range, but some of those early inverters that we showed you, we're seeing heaps of those still going 25 to 30 years on. And it's a great phone call when somebody rings you and they said, oh, my inverter's, sometimes they try to be funny and they say, I want to know if this is in warranty. And then you realize they've got their tongue firmly planted in their cheek, because it's just, the inverter is actually 25 to 30 years old. There's plenty of those there. So that's a real point of confidence for the customer. The other really important thing that we think that should be thinking about is, in a systems where everything is all in the one box, we're not seeing an ability for people to upgrade the batteries. It's like replace the box with a new box. That means you're replacing the inverter, you're replacing the solar inverter, you're replacing everything. From an environmental point of view, that's a disaster. We don't have that situation with the way we're building up our systems here. So when it's time to upgrade those batteries, then you're simply going to be just changing the battery, maybe a firmware update on the SP Pro. So we're not asking the customer potentially to be pushed into a technology corner, and others out in the marketplace we know are doing that sort of thing. No frequency shifting into the building. We've talked about that earlier, but certainly we do hear a lot of customers say, oh, we're having problems with LED lights or this or that. We don't have that problem. The customer decides that one day we want to connect to the grid if it comes through, or maybe go off the grid. No problems. We just have to reconfigure the SP Pro, and we're done. SP Pro is always having backward compatible software. So when the R&D team do a new firmware release, then that is backward compatible. Only once now in the 11 years that we've had the SP Pro out. Of course, the hardware is pretty well the same because it works. The software is what keeps getting updated, but it's only once that we haven't been able to be backward compatible, and that was just when we recently released the Powerchain technology. We couldn't make that compatible with the old Keiko grid inverters or solar inverters. That's the only time we haven't been able to do it. So we think that that's a real bonus. We know that backward compatibility is something that a lot of companies aren't interested in because it costs money. We get that. And we're able to offer up to a 10-year warranty to the customer. So there's some benefits that we see why a customer should be thinking about Selectronic. But what about from an industry views point of view? When you're doing your design, and I've spoken to a lot of you about design, but it's never just bread and butter stuff. It's always, this is a bit different, this is a bit, and that's where we sit in those slightly harder systems, but we have that great flexibility that allows you to get into some of those more bespoke designs. What that tends to mean, though, is that if you're not working in that gutter part of the market, which I think we all know what I mean by that, then you don't have to be fighting and scraping for GP, gross profit. And last time I checked, that was what paid all our wages, was when we actually make some profit. So I think this is something that you can actually really take and say, well, if I get this job, I know I'm going to make good money out of it. And that's what we're here to help you to do. You can put that SCERT in today, and then that's tomorrow's sales for storage systems. So you could look through all your sales that you've made of just SCERTs as a grid inverter only, and then add the storage to it later. And of course, you can grow these systems. So the customer comes back to you and says, hey, look, we need to, we're just getting smashed now because we use so much more power. What can I do? Well, we can just use our Powerchain technology to make that system a little bit bigger. And there's lots of talk in the marketplace, but I think when you're talking about a company that's 56 years old that has continually survived the storms and of the ups and downs of the solar coaster, and continues to support its people, its suppliers, and its customers like yourselves, then I think that runs on the board. It speaks volumes, doesn't it? And we don't saturate our product. That's really, to us, that's very important. We want you to maintain profit. It's really, really important. And that's why a lot of our customers we've had for many, many years. I'm looking at the screen of questions now, and one of the guys sitting there, he's been using our product for many years. And we do that by providing happy customers equaling a healthy business. Obviously, we make the appropriate amount of profit on these systems. Everybody is happy, and then we can go on to the next customer nice and happy. So local tech support, of course, that goes without saying from us, I think. I know after this meeting, Ivan will be disappearing because he's got to go and drive a couple of hours to help a situation out. And that's the kind of thing that we think is really important. When things get bad, we have to solve them quickly. And so that's what we'll be doing. All right, Ivan, any questions? We've got a couple there to answer.
Yes, so there's Nick has asked the question, can SP-Link update the customer on this with a notification? Nick, could you just put some more clarification in? I'm not quite sure what you mean there. SP-Link certainly provides update notifications if there's a new software version or so on that comes through automatically when you use SP-Link, but maybe put some more clarification there for us.
And David's asking, sorry, I thought we were doing one-on-one, sorry.
No, one-on-one, let's just go on with what works.
And Dave's asking a great question is, can we put a little bit more detail into, for instance, Select Live, why did the generator start? Why is it doing a few things that it's doing? And that's a really, really good question, David. It's an interesting, there's two parts to the answer is absolutely that needs to happen. And that is part of a review we're doing at the moment on those sorts of things in Select Live. But why doesn't it do it? It seems like a logical thing to do. And the way we looked at that in the beginning is you said, well, we're just doing what we need to do. What's the big problem? It's like if we're driving a car, we don't get notified if the turbo fan comes on. But things are different from when we first developed this. So totally agree with you, David. And yes, that's one of a host of features that we are looking to put into Select Live because there is so much data in an SP Pro. We know that we can add a significant more value than what we've got there now. And so, yep, that's certainly at the top of the pipeline at the moment. Well, it's not at the top, but it's very high up there.
Yep. So Nick's just come back with some follow-up. So essentially, it's about similar to David. Select Live providing a notification as to why the generator started. SP-Link currently has that detail in it as to why the generator started and why it's running. And as Lindsay said, we're looking at pushing that through into Select Live as well.
All right, some great questions there. Really appreciate all your input. That's what causes us to go over time, but that's fine. I think that's the value that we're adding, and that's what you're on these webinars for, obviously, is for us both to share some information. So we've learned some things today. I'd just like to highlight the little subtle part at the bottom of the screen right now, the world's most experienced inverter company. I never realized this actually until just a little while ago when I started thinking who was around when we made our first inverter, and none of the existing inverter companies were around. In fact, the closest to us is another Australian company, actually, a company called Selectronic. So possibly the two oldest companies in this market share is two Australian companies. And I think that's great, especially in this time of COVID where we should be supporting manufacturing. And unlike maybe some others, we're designed, we're manufactured, and we're also totally Australian owned as well. So Ivan, thank you for your technical input. Guys and girls on the other end, really appreciate you making the effort to come along and listen and share some of your thoughts as well. One last question by the looks of it there from Brad. Can we notify that the grid has failed through Select Live? Ivan, is that in the email alerts at the moment?
So again, Brad, it comes down to, it's similar to why we notifying the client when the generator started. We see that as normal operation, but we recognize that people like to know these things, even though the SP Pro is just dealing with it. So that's part of what we're looking at into the future. So thanks for that, Brad.
Yeah. All right. Thank you, everyone. We'll let you get on with your day now. Hopefully that means maybe going out and designing some SP Pro systems. We're here to help. Please call us, email us, whatever you need to do. We're here to help you through that design. So thanks for coming. Steve, one last question. Will there be an alert in the event of a generator failing to start? So all those things are certainly the areas that we're looking to improve or add additional value in Select Live. Absolutely. Yep. Thanks for coming, everyone. There will be other webinars. We're going to try and do them sooner than later on the next layer down of applications on what we've talked about today. So we've talked very much about the foundational things today. Now we'll go into a little bit more, particularly three-phase on-grid is something that we're looking to do another webinar on. But if you've got questions or suggestions on what webinars you'd like to see, please drop us an email. We'd love to know what it is that you need to know, and then we'll try and deliver that content for you. So enjoy your day. Thanks for listening. Thank you, Ivan, and we'll see you next time. Thank you.
Thanks, Lindsay. Thanks, everyone. Cheers. Bye-bye.